Hey everyone, I hope you all are safe and doing good. So, in this lecture, we will see multi-dimensional arrays. We have discussed till now arrays like 1D arrays, single dimensional arrays, and some operation to be performed on that arrays insertion, deletion, traversal. Although we are left with some more operation, searching, sorting, we'll see also that in later section. But for now, let me just give you a brief intro of multi-dimensional arrays. So, see, based on dimension, two types of arrays are there: single dimensional and multi-dimensional. Single dimensional we have seen in the previous lecture, simple array, those regular array or 1D array. These are single dimensional arrays. Now, multi-dimensional arrays means those are having more than one dimension. Means it's, you can say something like this. Here we have this is a single dimensional array, something like this, having one dimension only, one row and multiple columns. Now, multi-dimensional arrays, it can be 2D array, 3D array, and many more. But we generally don't visualize those arrays. We deal with 1D and 2D, maximum sometimes 3D. Otherwise, till 2D, like we use till 2D only. Okay. Now, what are these arrays and when to use these 2D arrays? See, if I want to store in my class, I have suppose 20 students and I want to store marks of 20 students. So it's okay, I can write simply like int. Suppose marks are not int, marks are like float. So float, and here I will write marks is equal to new float, and I can simply write here 20 students. So I can create an array, I can store marks of 20 students. That's fine. But I want to store marks of 20 students in 5 subjects. Subjects are also 5 and students are 20, something like this. We are having student this side. So we have a tabular kind of data, student 1, 2, 3 up to 20 student. And this side we have marks. Marks in 5 subject. So you can say subject 1, 2, 3, 4, 5. So like this we are having some data. So this is like a data having two dimension. One is row and one is column. So it's like in matrix also, you write matrix something like this in mathematics. We write like 1, 2, 3, 5, 6, 7. So it's a matrix of 2 into 3. Two rows are there and three columns are there. So if data is present in this form, tabular form, grid form, or matrix form, in that case, how to store this data in computer memory? We cannot store like data in tabular form or matrix form directly in the memory. No, memory is like it's a like sequence of those bytes. It's linear. So we can't store in tabular form. So for that we have 2D arrays. Okay. Now if you want to store roll number of marks of 20 students in 5 subject. Now how we can do? You will do one thing. You can do one thing. You can create 5 arrays. Subject 1 or marks 1, marks 2, marks 3, marks 4, marks 5. You have created 5 arrays and you can store marks of 20 students in 5 subjects. That's fine. But suppose students are 60 and subjects are 5. So I will not create 5, you can say, or 60 arrays, 61D arrays. Because it's nothing but if I store for student 1, if I store like 99 or we have 30 and 30 would be a little bit less. Let's suppose 80, then 78 and 79 and 60. Here also we have some marks of the student: 35, 45, 55, 65, 75, like this. So this is nothing but a 1D array, right? This is nothing but a 1D array. For student 1, it's for student 2. These are 1D array, 1D array, 1D array. Individual if you see. Okay. So now under the one variable name, you don't need to create like 20 arrays or something like this. Under one variable name, under one array name, we can store marks of 20 students in 5 subjects. Both the dimension, rows and columns at one place only. So that we can do with the help of 2D arrays. So basically we can say 2D arrays are array of arrays, because each individual row is a array itself. It's 1D array. It's 1D array. This is 1D array, 1D array. So something like this, how you declare a 2D array, we can write same the data type, but here two subscript, one for like you can say row and column. Here the name of the array, I'm just taking suppose marks is equal to same new keyword, then the data type, then here two subscript. The first is row size, second is column size. This is how you declare, that's it. This is just declaration, right? Like in 1D array, we have three steps: declaration, then instantiation of array, and then initialization of array. So same here, we have three steps. Just this you write, float this just like the reference to that array, 2D array. So this is declaration. If you write the complete thing means you have allocated the memory because we have used new keyword in the heap. Actual, you have created in the heap something. So it's like instantiation of the array. Now you have to give here. It's compulsory to give the row size. So row size, suppose I give here, I have suppose 20 students and column size is 5 subjects, something like this. So this is how you can declare and instantiate a 2D array. We haven't initialized it. By default, the values would be 000. Marks are 000. Right? Now, one thing I just want to tell you, it is compulsory to give row size. But if you do not write here column size, that's fine. It will not give any error. So it's not mandatory to specify here the column size. But this is a special kind of array, jagged array, that we'll see in this video only. But first, let's discuss the regular 2D arrays or the traditional 2D arrays. So for that, let's specify the size, but it is not allowed. Row size is not optional. It's not like that, just omit the row size and give the column size. No, this will give you error, compile time error. So this is compulsory to give, this is optional. Okay, now we have just created a 2D array. Now it's like we can say now this is nothing but it's array of 1D arrays. So 2D arrays are array of arrays, array of 1D arrays, forming like a grid like structure with some rows and columns. So it is used basically to store the data, tabular data, or if the data is in matrix form, if you want to deal with the matrix kind of question you want to solve, then we store those metrics using 2D array in computer memory. Okay, so these are organized. They consist of the elements organized in a rectangular format and accessible by two indices. How you index? Because obviously we are having one index, one is for row. If I want to access this 99, this marks. So you have to know in which row and in which column this is. So you need two index, one for row, one for column. Same indices start from 0 here. So 0 to like till whatever number of rows and number of columns you have. Basically, two indices you require to access a value in 2D array. Okay. So these can store like various data types from numbers to strings to objects. So same primitive types also we can store in 2D array as well as objects also. Arrays of objects we can also create, that also we'll see how. The basics are clear to you, I guess, about 2D arrays. Example is given same, like matrix is equal to new int 3 into 3. Now this is now initialization of the 2D array, have to put the data. So I think 2 3 ways are there. Same view initialize 1D array, same you can say methods are there. Either you can directly assign something like this. See 0 0 1, then it's 0 2 2. So it is like 3 into 3. So something like this we are having here. Or if you do not write in matrix form, so we can just write in tabular form. So here we have something like this 0 1 2 and 0 1 2. So this side we are having rows and this side we are having columns. So 3 into 3. 3 rows, 3 columns. Matrix, 2 index you need. So first index is for row, second index is for column. At 0 0 it's 1. So this is 0 0. So here we have 1 0 1 2. So 0 and 1 it's 2. 0 2 we have 3. So 0th row and second column it's 3. So like this is individual assignment using like equal to operator. We can just assign the values to each individual element. Second way is you can use array initializer as well. So how you can write in that case, if suppose I have this array int int, and let's take the same example. We are having matrix name. So new int. Here you don't need to give any size. Directly you give here the array initializer. But in that case, obviously it's 2D array. So it's array of arrays, 1D arrays. So you have to give something like this. For each, in each curly brackets, we are having individual row you have to give. 1, 2, 3. This is one row. I mean, this row. For second row, again, 2, 5, 6, something like this. For third row, 10, 5, 10. So here we have not semicolon, here we have comma. Simple. After that, we are having semicolon. So this is how you can initialize with some array initializer. Third way is you don't need to write this thing directly is equal to, you can assign this, and this array initializer will handle everything. Calculate the number of rows, number of columns in each row, and according to that, it will decide the size. You don't need to write new int and something like this. So here we're using array initializer, right? This is how we can initialize it. So why basically now we need 2D data, 2D array? If the data is in tabular form, matrix form, in that case, to store that data, obviously to handle that data, you will need 2D arrays. And it allows for some, you can say, intuitive representation of tabular data in grid. Intuitive means we can visualize data in tabular form. So 2D array also we can visualize in data in tabular form. So it will give you intuitive representation of that data. Especially in game development, these are used. Suppose we are having like a chess. There we have chess game. So for each this kind of thing, for each like that player, there is two position, this and this. So obviously in game development, many of these kind of these kind of games, 2D arrays are used. Okay. In image processing also, for matrix operation, you need 2D arrays. This is simple declaration of 2D array. I have told you. That's it. Data type, these two brackets, and the name of the array. Simple. Now, this is like you can say declaring a 2D array. So this is a Java example, and this is generally we call it C style or C++ style. After array name, you give these subscript and the row size and array size. Here, before the name, before the name of the array, you give this these two brackets. So this is recommended in Java. It's not like that you cannot use this kind of thing, but this is recommended in Java. We use this thing, right? Instantiation of 2D array. We will see. We will try to use this thing also. Let's see it will work or not. Instantiation means memory allocation of 2D array. Obviously, you have to specify space is reserved in the memory for the specified number of columns and rows. Okay. And it's like array object creation. So a reference to the newly created 2D array is returned. Whenever you instantiate the array, then what is going to be returned? See, a reference, because that name is the reference only. It will not contain the actual data. Reference to the newly created 2D array in the heap is returned. So now you have the reference. Default value we know for int it's 0, for objects it's null, for strings it's null, and we know the default values. Now this is instantiation of 2D array. Just a simple example. We'll see practically also how to initialize. Direct initialization is done. Assign the value to individual element, or we can use loop also. This also we'll see how using loop we can initialize the arrays at runtime. Don't worry. But for this you need nested loops, because in array we are having number of rows, number of columns. Okay, this thing I'll show you. So directly this is how we can assign in Java, or you can write this thing also. Both the things are allowed. I have shown you this thing. How to access? You need row index and column index. So simply you give that thing and you can easily access any element in that. So ensure indices are within the array bound to avoid runtime errors. So otherwise you will get array out of bound index exception. So this is how we can access the array elements. I'll show you practically these things. Don't worry. You can simply write the index, like if in the array I am having something like this. It's a 2 into 3 matrix, 2 into 3 array I am having. 10, 5, 6, and I am having some values here, right? So this will give what it will give matrix 1, 2. The name of this is suppose matrix. Matrix 1. 1 means number of index of row is 1, index of column is 2. So it will give you 8. It will give you 8 in this case, and the value we have 8. You can modify a special any element here. Simply you can set matrix 0, 1. So 0 and 1, this element is equal to 42. It would be set to 42. Yes. Now, if you want to print the entire matrix, it's like traversal of the matrix. What you will do? Obviously, there are two things, two dimension. One is rows. In every row, we are having some columns. So we need two loops, two nested loop. First, the outer loop will handle the number of rows, right? Because the first loop, see, this is the outer loop. I is equal to 0 and I less than number of rows. Within this loop, now you have to print because now I am at 0th row. Now one more loop I need to print whatever the element in this row. So from this to this, you have to run a loop again. So it's inside this we are having, inside this we are having one more loop. J is equal to 0, j less than columns and j plus plus, and then we print. So we need nested loop to traverse a 2D array or to deal with 2D array, to do some operations in 2D array. So time complexity basically would be, in this case, nested loop. It takes how many times this line would be executed? N square number of times. Order of n square. Because see, for this 0, if I is 0, see, if I write like I is equal to 0. So number of rows are here 2, number of columns are 3. Condition true. So enter here. Now j is equal to, j would be 0, then 1, then 2, less than columns. Number of columns are 3, so j would be 3. So this line would be executed 3 times. 3 times here. Once I becomes 1, again j would be 0, 1, 2. So again 3 times. Once I becomes 2, condition is not true. So 3 plus 3, total how many operations? 6 operations. Right? How many times? 6 times. So here we can write, in this case, we cannot write basically n square. Here in this case, what we can write? Because the loops are, the sizes are different. So n square is not correct in this case. You have to take care of this thing. It's rows, it's columns. So maybe rows are 2, columns are 100. Maybe rows are 50, columns are 1 million. So we cannot simply say n square kind of thing. What is the situation here? Rows into columns. Order of rows into columns. This much time, because 6 times this would be printed. So it's like number of rows are 2, number of columns are 3, so 6. So this into this. If it's n, m, you consider generally nm. So m into n. This would be the time complexity, right? If both are same, number of rows, or n, n, or m, m, then it's obviously square, n square, m square, or something like this. Okay. I hope now you got time complexity of this. Now, one more important thing, how actually in memory, obviously this is not to be stored in memory actually in tabular form. So how actually in memory 2D array is stored? That thing is also crucial. And are these elements in the array of 2D array in Java stored in contiguous memory locations like 1D array? Let's see. So after execution of this line, what will happen? We have now ARRs. Obviously, we are having like in stack, there would be one main stack frame or activation record for this, and for here we have ARR. This is reference, and there is some heap. So see, there are two sections. So this stack grows upward and heap grows downward. So you can either represent something like this, or I represent something like this only. So in heap, actually, now what is happening? An array has been created having this. See, int 2 rows and 3 columns. Okay. So this is array of 1D arrays. So what is there in this case? Basically, if tabular form I represent, then this 0, 1, 0, 1, 2. Two rows and three columns. How many 1D arrays are there? One is this, one is this, and one is this. This is nothing but a 1D array. So 2D, 1D array. So this is a reference variable, and here we are having this is array of 1D array. How many 1D array basically? It's two 1D array. So this is like here something like this would be created, and this individual is 1D array, 1D array, and it is referring to this. Means here we don't have actual data. Again, the data would be somewhere here. We have three columns now. This individual element of 2D array would be itself a 1D array. So it itself contains the reference of that 1D array. So here we have this 1D array, here we have this 1D array. So this is like row 1 and row 2. So suppose the reference of this is 1000. So here we have 1000. Suppose, I don't know. Now in heap, this is array of references. This array is for array of references. Okay, here also we have reference, here also we have reference. Actual object is somewhere, actual array is somewhere else in the heap. And this can be created at random memory location. It's not like that. Once the data is suppose 1, 2, 3, 1, 2, 3, and consecutively in next memory block, the next array 5, 6, 7, 5, 6, 7. No, this can be anywhere. This object and this object can be anywhere in the heap. These are not bound to be contiguous. It is handled by JVM. Okay. So now this is the case. Now this the address of this is suppose 5000. So here we have 5000. It is suppose 10,000. So here we have 10,000. So this is how actually the memory is a representation of a 2D array. These actual objects are not contiguous. It's not necessary that it would be contiguous. These are somewhere in the heap at different locations. So I hope you got this. So this is like outer array. These are inner arrays. This outer array contains the references of the actual data or actual 1D arrays. Right? If you want to access this one, then obviously at first we know this thing only because we have this. This will return reference to this. So we have only this. We know the address of this. So through this we can go till here. How to access? So ARR of 0, ARR of the 0, 1, 0, 1, 2, 0, 1, 2. So ARR of 0, through this 0 we go here and 0. Then you will get this one. That's why we need two indices for row and column. So this is how memory is to be allocated for 2D arrays. Now let's see some practical, how to declare an array, how to initialize and all. Okay, so in our project data structure and algorithm, we are going to create a new Java class now. We are discussing 2D arrays. So how to declare something like this, int this, and suppose you're having ARR, simple. Or let's say marks, for marks, double. Simple. This is simple, the declaration. So I cannot simply print here marks. It will give you error because this is not initialized. And by default, it is local variable. So by default, there would be no default value. If it is that class level variable, here you write, then it will contain null. But right now, variable, this marks might not have been initialized. You will get this kind of error. Now let's instantiate this. So how to do this thing in a separate line. So we are having like, or don't need to write this thing obviously in a separate thing if you want to write. So marks is equal to instantiation means we are just allocating some memory. So obviously we need a new keyword. New double. Size is 2 and 3. Simple. Now marks will give you null. Sorry, not null. Here we are having something, some address, because we have created in heap that object, actual object. So obviously marks is reference, so it will have some address kind of thing. So double these are 2 times this bracket we are having, so it means it's 2D array. So D is double at the rate some address is there. But see, We don't know the actual address. So because you know that in Java, basically memory addresses for these arrays are abstracted away from us by the JVM. JVM handle everything. So we don't need to know the actual addresses, and we don't know the actual addresses basically, right? So now initialize. Now let's initialize. I'm just doing in the same line only. So let's write down this also within the same line. Marks is equal to new double this, and you can just ignore this. See, it will not give you any error because this is optional. But you can't write something like this. It will give you error. See, not a statement. So you have to give the size. Now at the same line, if you want to initialize, or individually if you want to initialize, suppose I have just this and this. So what you need to write? Marks 0 and 0 is equal to, you can put some marks, and like this you can initialize. So 0 1, one row we have initialized with some marks, suppose 94, 96. So like this. But if you want to access this thing, now marks of 0 and 1 I want to access. So what it will print? Obviously, what are the marks there? It's 94, so it will give you 94. But if you want to print marks of 1 1, it will give you 0, 0.0. See, because remaining marks are by default 0. We have initialized only three, only the first row only. So if you want to access on the second row, it's 1, row index is 1 and column index is 1. So that is 0. But this is individual assignment. I don't want this thing. This is a really lengthy. So I want to use array initializer. So simply just remove the sizes, and here simply write down. That's it. So we have given marks within this. See, nested brackets are there, curly brackets. So this is for first row, this one. This is first row, this is second row. I mean row 0, index 0, and row 1. Something like this we can do. We know this thing. So right now if you print 1 1, so it will give you 78. See, 78. Right now you can delete this also. That is also fine, and this will work. You run this and it will still give you 78. So you are using arrow initializer. That is like a shorthand for the declaration, instantiation, and initialization in the same line. Okay, this thing I think clear to you. How to access? We know row index and column index you need to give. Now what happens if I want to initialize this at runtime? I don't want to take from user like at compile time only. I want to take from user at runtime. Okay, let's delete this. Fine. Now we are taking marks from the user. So let's just print this line, enter marks. So obviously you need at first the 2D array. So we have rows and columns. So first you have to go to row, then in which column you want to go. So to traverse the number of rows, there is outer loop we know. So I is equal to 0 till I less than number of rows are here fixed. We know 2, suppose. So it's 2. Let's write 2 and I plus plus. Right? It should be I equal to 0. Within this, now we have in every row 3 columns. So you have to traverse every column as well. So for second loop would be for j less than number of columns are 3 in this case. So j plus plus. And now we just enter the marks. So marks of I j is equal to, for that you have to obviously create a scanner object. And system.in we pass because we are taking input from standard input, that is keyboard. So simply scanner dot next double. That's it. Right? Now we have taken the input, but let's print also. So it's like traverse this 2D array as well. How to print? Same unit to loop we know. So let's just copy paste this. Outer loop will run till number of rows, till number of columns, but rather than taking input, now we are printing. So let's just print. Paste this line here, and rather than 1 1, we take I and j. I hope this is not a rocket science. You got it. You can just write on this and you get it everything. And this thing we have also discussed when we were discussing arrays in our Java course. Okay. Let's run this and see. You have to little bit decorate it. Let me show you the output. Enter marks. Okay, sorry. 1, 2, 3, and 3, and these are the marks. But I need, like, obviously those you can say rectangle or matrix form, the marks, right? So simply what you need to do, you cannot simply print something like this. We can do is just print first from the 0 through all the marks. Then after printing this, after this inner loop, a new line. Insert a new line and then again second row. I want to print. Okay, let's run this and now see. So it's not a big deal. I think you can easily decorate it after, whatever what kind of output you want in which format, you can easily write down, modify your code. So still we have some, like, you have to, after these marks, please add some space so that it looks good. So like this. Okay. But now I don't want to use this traditional loop. I want to use for each loop to print this. Okay, let's just comment out this thing. And you know the syntax of for each loop. So let's write down for each loop. So for, but the thing is, after some element, here I write like the data type. So data type is double. Sorry, data type of the same is double. After this, suppose I write simple double and element, something like this. And after that, I write whatever the collection name. So collection name here is, the array name is marks. So I write here marks. What do you think? It is correct? Marks. No, it's not correct. See, it is giving you error itself. Provided is double, but required is double array. Because marks, this marks itself, it's an array of 1D array. Let me show you. Hello. See, here suppose I am having marks. The array name is marks, not ARR. So this marks, this is basically the name of this is marks. We have this. So this marks, this is what? This is array of, containing array of, it's array of 1D arrays. It's containing 1D arrays. So if I access simply this thing, this ARR of 0, ARR of 0 or marks of 0. Here I've changed the name. So it's marks of 0. Marks of 0 is this. So it itself is a reference of this. So it will give you the complete thing, 1, 2, 3, something like this. Right? It will give you, here we have a complete array, you can say, because this is a reference of this. So it's like it's a complete array here, it's a complete array here. So whenever you write for each loop, something like this, I'm writing here for, and the array name in our example, it's double and element. Suppose I write this thing and marks. So what for each loop will do, whatever in this collection, the first element would be assigned to this, whatever the element you take here, the name you take here, the variable name. But it will give, here itself is an array, 1D array. Here itself is 1D array. So it will return, the first element is 1D array. So it will assign 1D array to this. So it should be of type array, 1D array. Right? So here we have to write double and this bracket. It should be 1D array. Simple. Now in element we are having the address is like 1D array. So for traversing this 1D array, we need again a loop. So for each loop again. But this is 1D array element. So in this we are having 1, 2, 3, something like this. So whenever after column, I will write this name element. This is 1D array. So the first element of this array would be assigned to whatever you write here, the variable, and that would be 1. So it is a simple variable. So here you can write simple variable double and suppose x. Within this now you have to print x. So same, you need nested loop definitely, whether it's for each loop or that you can say traditional for loop. But I hope the syntax is clear to you. Why in outer I'm taking the type of this as array, and within inner loop I'm just taking the type simple, simple variable. Here I'm taking an array. And now x is simple, the variable 1, so you can print simply x, then x would be 2, then 3. And after that, this end of this element, so out of this inner loop and go to the outside loop. Now next element in this marks is this, so this is also a complete array, so next array would be assigned to this array, that is whatever is there here, that would be assigned here. Now we traverse that array. So this is working for each loop or enhanced loop. I hope you got this. Let's try this out. That's why it is giving you the error. Provided is double but required is this. So change parameter to this. Within this now you need one more for each loop. So double and x, and the name is element only, and let's print here. Same. You can just print here what? X, and after printing I need some space, and then after the inner loop I want a new line. Let's run this now. See, you got it. Same time complexity. If I ask you, obviously it's nested loop. So if I ask you the time complexity for this complete program, then you just leave it. You can just leave these lines because these are constant time and all. But for this, it's nested loop. So 2, 3 sizes according to this. So you can say order of m into n. For this also nested loop. So for this also we can have it's m into n. So mn plus mn, that would be 2mn, that this kind of thing. If someone asks you only for traversing or the printing of the array, what is the time complexity? There is nested loop, so it can be order of mn. That's it. M into n. Is here in this case loop will run till whatever the elements in marks, and here in this case this loop will run whatever the number of elements in this element in this array. So the element within this, the number of element within this number of element can be different. So it would be m into n kind of thing, right? Now these are all about regular arrays. Now in Java it's possible we can have, I have told you, don't write this. It's allowed in Java. Okay. But in this case, what happens? We know the number of rows, but we don't know the number of columns. But here I'm writing less than 3. Let's run and see. Null pointer exception. Why you get null pointer exception in this case? Because there is no columns. So okay, we have 2 rows. Every row will have like some 1D array. But in each 1D array, we don't know the number of columns. So how actually that would be created in heap? So that is null. So that's why it is giving you here the null pointer exception. We cannot run till like something like this. We cannot do this. Let's just comment out this thing and I'll show you here. If I want to access marks of 0 and 1, 0 and 0, sorry, 0, 0 is equal to, let's store here 89 and then print the marks. What do you think? What output you will get? Let's run this. It will give you some exception. See, null pointer exception. Cannot store double array marks 0 is null because marks 0 is null. Why it is showing this thing? Because see, here we are writing something like this. Just delete this size. We don't have anything. Now we know, okay, it's marks. So it will like something like this. We are having 2 number of rows. So definitely 2 number of rows are there. 2 rows are there. So every row is 1D array. So we know it's 1D array. So here we have 1D array, second 1D array, 2 1D array. So this has been created. Okay, fine. Now, actual here, how many rows? Actual objects are there or not? No, because there is no column size. So how to create these things if you don't know the column size? So they, in this case, there is nothing. We have only this. So these are not referring to anything. And by default, if these are not referring to anything, we know here we have null by default. The objects are null. Yes. And now you are accessing marks of 0 and again 0. So where is that again 0? There is nothing. So marks of 0 is null. Marks of 1 is also null. You cannot access in this case. This syntax we generally used when we want to use jagged array. Jagged array means arrays with irregular data, means irregular number of columns in the row. Suppose, let's take this example. Here I don't want that my each array should take fixed number of columns, or like all the rows should take fixed number of columns or same number of columns. Here I'm having this row is having 3 columns, this row is also having 3 columns. So this is like regular arrays, but I want this kind of thing, this kind of thing. Here I'm just having 3 in the first row, and here I'm having 4. Again, maybe I'm having only 1. So this is row 0, 1, 2. Here I'm having 1, 2, 3 columns. Here 4 columns. Here only 1 column. This kind of data how to store? For this, we have jagged array in Java. It's not in C and C++ inbuilt. Yeah, we can achieve with some pointer kind of thing. But in Java, it's inbuilt. We can use jagged arrays. So you have to write down something like this only. So we have suppose ARR. ARR is equal to new this. We need only, if I take this example, 3 rows, number of columns are not fixed. For each row, number of columns are different. So I'll not specify the number of column. But now you have to specify. Because if you write this line, what will happen? In stack, we know this ARR. In heap, this is referring to something like this. And there we have number of rows are 3. So 1, 2, 3. Right now, null, null, null. There is no actual object. Right? Now you have to create. You have to create in this heap the object for this 1D array, actual 1D array where the data is to be stored. And then it will refer to that. So you have to create, you have to allocate the memory. So we know to allocate memory, we have to use new keyword. So how to use? Just access this. So this is like array of 0 is equal to new of type int. How many this in this how many rows, or you can say how many basically columns you want? 3. So 3. Because we know this is 1D array. So here you give only one dimension. It's 1D array. So now it will create 1, 2, 3, and now it will refer to this. Now it's fine. Now you can assign any value to this. But still you cannot assign any value to this 1D array because it's still null. If you want to create, again you need to write what? ARR of 1 is equal to same. You have to create, allocate the memory explicitly using new int and 1, 2, 3, 4. 4 columns I want in this row. So 4. For next, you can just write down new int 1. That's it. So explicitly in the case of jagged array, if you are using, you have to write down this thing to access the data. If you want to initialize now, you can initialize and you can just same traverse this jagged array as well with the nested loops you need, whether it's traditional loop or for each loop. The only difference is the jagged arrays are arrays with irregular data. In this array, then the rows are having different number of columns. Okay, so sometimes when we have irregular data, that kind of thing, in that case we store we that data in this regular in this jagged array. Suppose I have like marks of the students, but some students are having only 2 subjects, some students are having 3 subjects, some students are having 4 subject marks in 4 subject. So how to store? If you use the traditional loop plus something like this, I have the data is something like this. I have for student 1, student 2, student 3. There are only 2 subjects. Subject 1, 98, 97. For student 2, I am having 98, 99, 90. And for student 3, I am only having 178. This data I want to store. So here we are having 2, then 3, and here I have only 1. If you use the traditional array, then obviously you need to allocate three number of rows, and the maximum number of are three, so three columns as well, three columns to for regular arrays. But here I don't need, that is wastage of space. So in this case you have to, it is like, it will give you memory optimization. You can save the memory using jagged arrays. So individually assign the value for this, just assign here 2. Once you create this, assign the memory for 3 elements. Once you create this, assign the memory for 1 element. So extra space you don't need. So it is going to save the memory a lot. So when you are using with sparse data, this kind of data you have in some cases, then better to use jagged arrays. Now let's see practical. So now what you need to do specifically for like marks and 0 is equal to assign. Now new, allocate the memory new, double, and suppose in the first, suppose I just want to store uh, marks in two subject only, and for second, marks of 1 is equal to new, double, for this 4. For second student, subjects are 4. Now you can assign this marks of 0, 0 is equal to 89. That will give you 89 only, the output. And if you don't want to give this kind of thing, you can initialize this jagged array here itself. So here I can write something like this. Let's just comment out this thing, and you don't need to give any size and all. Here only just give the list. Simple. So in the first, okay, sorry, here we have comma. Here we have semicolon. So this thing is also allowed. It will automatically create, you can say calculate. There are two rows, and in first row we are having only two columns. In second row we are having four columns. So this is nothing but jagged array. Now, one thing, when you enter the data in the jagged array at runtime, then what will happen? See, here also we have done some kind of thing. We have, hard coded these value, but that is obviously not a good idea. So you have to change it. How to change it? Let me just show you that thing also. So first let's import for scanner, import class this util load scanner. Create a new scanner object, enter marks. Now I'm not taking marks here, but what I want is, there are two rows and this kind of marks I want. So let's just comment out this thing. In the first row only two subject, in the second row only four columns or four subjects. So I'll not specify this kind of thing, right? So I have just created these actual array objects as well. New double 2 and 4. Now I want to enter the marks. Just want that user will enter the marks. So outer loop will run till we know the number of rows. So number of rows we know it's 2. But I'll not hard code this thing. How to get this 2? Can I simply write this? If I write down marks dot length, then it will give me 2 also, 2 itself, right? See. Okay, here. So what I'm just writing here is, try to write is, array name is ARR in this case, but in for loop will run I from 0 till number of rows we know here in this case are 3. Okay. So 1, 2, 3. But now ARR is equal to 1, 2, 3, pointing to this. So if I calculate this, I should be less than whatever ARR dot length. ARR dot length means length of this. So it will return 3 itself. So why to hard code the value? Just put ARR dot length and I plus plus. Okay, outer loop is done. What about inner loop? J is equal to 0. J less than what? Now J handle the number of columns we know. But number of columns in every this 1D array is different. For first, it's 3. For second, it's 1, 2, 3, 4. For third, suppose there is third one, it's 1. It's 1. It is pointing to this, it is pointing to this. Now, when I go for this row, the inner loop should run till number of columns are 3, so less than 3. When I go for the next iteration, Suppose I is 1 for the next row. Then the loop should run till 1, 2, 3, 4, less than 4. After that, the inner loop should run till like one time only. So inner loop is changing, na? We can't hard code the value. How to get this thing? Just think, pause the video and think about this. So what condition I can write here? This like this. The name of this ARR of I dot length. Can I write this thing? And J plus plus. Here I write J plus plus after this. Here I am having array. So it is pointing to this. Because ARR of I, at first I is 0. So ARR of 0. ARR of 0 is this. Here we are having obviously that 1D array and length of that. So length of that array is 1, 2, 3. So it will give 3. In next iteration, I becomes 1, I plus plus. So ARR of 1 means we are accessing this. Here also obviously we have reference of at 1D array. In what that 1D array length is 1, 2, 3, 4. So it will give you 4. Next time it will give you 1. So problem solved. Don't have to hard code the value. At first, just write down this. Second, inner loop, write down this condition and then enter the value. Or if you want to traverse, then also condition would be same and just print. While entering, just take the value. That's it. I hope you got these conditions, right? Let's show you practically. So it's marks dot length and inner loop will run till marks of I, then dot length. And then just we are taking the marks. That's it. And if you are using the same traditional loop to print the values, so let's just copy paste the same thing because the condition would be same, but rather than here taking input, you just print. Now let's run this and see what happens. So we are going to enter marks. So for first, there are only 2 columns. For second row, we are having 4 columns. And that's exactly we want. For first, it's 2. For second, it's 4. Right? And uh, same you can do with this regular 2D arrays. So here, rather than writing 2 and 3, you can simply write the same thing. Marks dot length for this, marks I dot length for the inner loop. I hope you can do this. But if you're using this for each loop, obviously you don't need to handle this situation, don't need to write something like this. You can simply write this thing only. So just try out to print the array with for each loop. This jagged array with for each loop. This loop. We have done with the traditional loop, right? Now one more thing is there. We know we have a toString. If you want to print an array, then we can simply use arrays dot, we call that toString method and simply pass that array and it will give you that string representation of that array. So in 2D array, if you want to represent, then there is a method deep toString. So rather than printing this, let's comment out this thing and just write down a simple line. This arrays dot, we have deep toString method and just pass the array. Array name is here marks. Let's run this and I'll show you. First, you have to enter the marks. See, but this will give you like obviously in a string format. So this first row, then comma, second row in a single line. But you don't need to write down the loop and all if you want to use this thing. But same if you don't want to use this, and you can use this loop as well. See, I'm just removing this. Suppose for each loop I'm using. So double element this, then next element this. Now I want to print here using that arrays dot toString kind of thing. So rather than writing this thing, just delete this. And here we are having that array. So simply here I can write system.out.println and arrays dot toString because here I'm having a simple array. For 2D array, you need deep toString, but in element is a single array, 1D array. So just print the element. And after printing this, let's run this and see. So you will get here something like this, one row and second row. So simply you can use two string also, but here this would be in one for each loop. But see, again, it's not like that it will give you order of n time complexity because you are using a single loop. No, if you go to this here also, you are calling this method of arrays class. So if you go to this toString method, it itself, see, this is toString in arrays class. So it itself is having this loop, right? So for this also, it's order of n. So it would be ultimately nested loop itself. Okay, don't think that in this case it would be order of n itself because there is only one loop. No. If it's a simple statement, then it's order of n. But within this, you have to find out what you are writing. Here I'm just calling again a method. So you have to calculate the time complexity for this method as well. So if you go to this, I've told you that there is something like if else and this kind of thing, but there is again a loop. So generally it's order of n again. So order of n square itself to print 2D array. Now one more thing I want to show you. We had done with array of like primitive type, 2D array of primitive type. But what if arrays of objects? Because we know 1D array in this case we have seen we can create array of objects as well. So same we can create 2D array as well, like of objects. So suppose we have a class, same example let's take. We have here only two things, name and roll number of the student. And now for this I want to create 2D array. So the syntax is almost same. Student, the type is student here. Two brackets. The name of 2D array, it's students is equal to same. We are taking here int and the name is, so the data type is student 2 and 3. Same size. You can take any size. So number of rows 2 and number of columns are 3. But in this case, what is happening actually in that memory? See. So we have here stack. We are having in this a reference students. And suppose this is like we have some heap memory and there new student we have created. So 2, it's also 1D array and 1D array. For this, we have 1, 2, 3 and 1, 2, 3. These are referring to again some reference and this is referring to this. These are referring to these 1D arrays. This is the thing. Okay. But now here the twist is it's not like that the actual data is stored here only. Like name and roll number, name and roll number, name and roll number. No. Because this is like a class object. These are not primitive type. If primitive value is there, int, double float, these are directly that would be directly stored in this array. But these are not primitive type. These are of like class type. So we are creating actually the object of this class. This is array of 2D array of objects. It's not array of those simple primitive data types. No. And we know that you have to actually create the object with new keyword. So again, you have to create the actual object here to store here name and roll number. Name and roll number. For this also name and roll number. For this also name and roll number. So like this. This is the twist here. I guess you got it. So now you have to create again. So how to write students, because we can access this thing. If you want to create this, you have to go through this, then this, then this. Actually, we are having this only, this reference. So we know the students. So students access this 0, 1, 0, then this 0, and now create this. How to create? We know you have to use new keyword to allocate memory. So new, and now the type is student. Student constructor, and now this would be created. Here now you can store the value like sorry, how to assign the value like students 0, 0 dot, I want to access this name, so dot name 0, 0 dot, here we have name and roll number, so dot name dot roll number is equal to, I can have like Jenny, something like this you can write, or students 0, 0 dot roll number is equal to some roll number 22. So this is the only difference in 2D arrays of primitive type and arrays of objects. This thing I guess you got it because in the previous lecture also the same thing was happening. right? In the 1D array also it is happening because here we are creating objects. So these are not creating the actual objects. Actual objects you have to create and then like you have to assign. Let's see now practical. So within this only, let's outside this, let's create a new class student. Okay, this is already there in this because we have taken this class in the previous example as well. Here we have array demo. So let's create a new class employee. Okay, now we have a class. So this now in main function, so in main method, here let's now comment out everything and create object of employee. Object means 2D array of the objects. So we have employees is equal to new and the type is employee. Employee to give the size 2 and 3. Simple. But here if you simply want to print, suppose here I want to print employees and let's access 00. Let's run this. So it will give you null. See, because employee 00 is null. See, we have only done this thing. Suppose rather than employee, here we have student. So I want to access, we haven't done this thing. These lines are not there in a program. And I just want to access something like this students 00. I want to print this thing. So students 0 means we reached here. Again 0 means we reached here. And it is printing null. I have told you now here the actual object is not there. You have to create actual object and it will store the reference to that object. So right now the reference, because you haven't created any object, so it's null by default. So here we have null, 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 everything, everywhere we have null. So that's why it is printing null, right? There's no default value. If you access this dot name, what happens? It will give you exception, null pointer exception, because this is null and you are accessing the name, so it's null pointer exception. So first allocate memory to it. Create actual object with this line and then you can access. Let me show you. So here it's null. And if you want to access c dot name, it will give you exception. Let's run this. It will give you null pointer exception. I have told you because it's null. See, null pointer exception. Now for that, you have to first create the actual object. Have to create, you have to reach till there. So employees 0 and 0. Now create here the actual object. Assign the value new and type is employee. Simple. And now you can assign the value. So employees 0, 0. I want to assign name. So dot name you have to give is equal to Jenny. And if you want to assign the that ID as well, so there 00 dot emp ID I can access and that is maybe like 1 to 2. And you can simply print name and ID. So I'm just printing here name, so it will print Jenny. Something like this is happening. So for that, for this to understand, if you are still confused, just draw stack memory, heap memory, and visualize this thing. Have that diagram with you and then dry run this thing. Then you will get it. It's not really, it's very easy. It's not tough. It's just overwhelming for you a little bit. But if you have the diagram for the memory representation for this, and you know how these are represented in memory, I have told you, then it would be very easy for you to get. And if suppose you want to print employees dot length, now you tell me, just think about it, employees dot length, what it will give. So let's run this and it will give you obviously 2. So same for this also, to take the input and all, we can have a loops kind of thing. So you try out this thing now with array of objects as well. Try out with loops, print the values with loops, and for this also try out jagged array. Don't just write down this thing. Take a jagged array. In this case, if I run this, then what will happen? It will give you some exception. See, null pointer exception cannot store to object array because this is null. Because okay, the rows are 2, so one array has been created having two these 1D arrays, but those 1D arrays have not been created because you haven't given the number of columns. So explicitly you have to write here what? employees of 0 is equal to. Now create, allocate the this thing. New employee, and I want columns 3 like this. Okay. If I run this right now, now it will work. See, I hope you get this. If you got this thing, this kind of thing with the jagged array in the previous case with primitive type, you will easily get it. You just have to think a little bit and that's it. So first, obviously, you have to assign, create that. You have to give the number of columns for that, and then you can just access those locations. Okay. After creating actual object, and then if you do not create this actual object, still, then also you will get here exception because there is no actual object exist. So again, null point exception you will get. Cannot assign field name because this 00 is still null. So for that, you have to again create the actual object, something like this. These two statements are really important, and then assign these things. So now you just practice with this thing, try out for loop and all, for each loop and all. So now let's you try out. Now pause the video and try out this. Use for loops. We have done, we have jagged arrays. So we have done like for employee 1, like for the first row there is only one employee, in the second row there are two employees. Now using for loop, to enter, you enter the values of all the three employees and display that in that matrix format or proper 2D format. I don't know, like it would be like, maybe it's not beneficial, maybe you will not use it later in the project, but it's just for practice. You will get to know that you got it or not. So like this, you have to print something like this. If I run this and I'll show you, it will ask like enter first employee detail. So I'm just entering the detail here, Jenny and 123. Then second employee detail, there is something wrong, Pradeep, and suppose 1 to 4. And for this, it is not asking like enter third employee detail, but it's like you have to enter because in second row, there are two employees. So enter for two employees, right? So here we have like Akash and 1 to 5. And it is showing me the in 2D array, like the first we are having only one column, in the second row we are having two employees. So something like this, it is showing me how you can do this thing. Let's just try out. Pause the video and try this out. So I guess you have done this. We simply, this thing we have done. But first now you have to create the actual object, three objects because three employees are there. Then with for loop, simple we know the you can say the I've used traditional loops. So the condition employees dot length and inner loop will run till employees I dot length. And then you have to just enter name and EMP ID. That's it. Okay. Or this thing, rather than printing here, this line you print here, I guess, within this. And if you want to print, same loop you require, right? But right now you have to just print the name and EMP ID. That's it. I guess it's not that much tough. It was just a practice for you. Maybe you'll not use this exactly same thing later. But why it is printing two times, enter one employee detail. Okay, you just comment out this line. Let's run this now. So let's enter the details. Okay, you can't write down that line here. You have to just adjust that line somewhere else. It should print enter second employee detail, or because it is running again for the next row. So same for the next row, it is asking first employee detail and second employee detail. So you can print here something like this. Enter like for row second, the first employee detail. For this, for row one, first employee detail. Something like this you can print. But the main motto is, I guess, clear to you what you have to do. So it should print something like this only, right? It's not tough. It was just an exercise to get you familiar with this loops and all. That's it. You can use this for each loop also for this. So we are done with this memory representation. Then initializing 2D array at runtime with loop. This is how runtime initialization with loops we can do. And with for each loop also I've shown you for each loop with 2D array also. That is also not that much tough. You can easily do this thing 2D array. This thing we have seen. Advantages, same, fast access. Directly you can access randomly any data with just index you have to provide. That's it. Intuitive structure, obviously matrix operation we can perform easily. Intuitive means it's like a natural representation of that tabular data. 2D array also in the same like you can say structure we represent this. We visualize this actually. So it's more of intuitive representation for our tables and grid kind of data. And definitely compact representation of the tabular data in memory. It's like you can say efficient storage it will give you. There is no extra kind of references you need to store, like in linked list we have to store. Drawbacks, fixed size, we know arrays are of fixed size, and memory is wastage because in inefficient for sparse data where many elements are empty. But in this case we can use jagged array. We have a solution. Okay. Application in game development, in image processing it is being used, and in data analysis these 2D arrays are being used, right? Now there are some exercises for you. You can go through this matrix addition, transpose of a matrix, and that's it. Now this is all about 2D arrays. I guess you can easily find out the complexity as well, because that is not that much tough. There are two loops, nested loop, then it is order of n square, but it depends the size. If the size or the termination condition is different, for outer loop it's different, for inner loop it's different. So it would be m into n, not m square or n square. Okay. I guess that these are simple program we have done. So please calculate the time complexity and space complexity as well for each whatever we have done in this video, the practice problems. Okay. So that's it for this lecture now. In the next lecture, we will see linear search, how to perform searching operation on arrays. So now we'll see you in the next lecture. Till then, bye bye. Take care.